All right, so the next lesson we're going to talk about is linearization. So linearization is just saying that we can use the tangent line at a point really, really close, and it should give us a pretty darn good estimation of it. So all we're doing really is using the tangent line. So remember, we practice tangent lines a lot. You need a point and you need a slope. So you should always say, I need a point and a slope. How do I get them? And then we're going to use that line in order to do stuff. So first right here, it's just asking us to do a tangent line. So whether we say find the linearization or find the tangent line, they mean the exact same. So we need a point first. So I'm going to plug 0 into my equation right here. So my point is 0, 1, because the square root of 1 is 1. So there's my point. And now I need a slope. You get a slope by taking a derivative and equaling it to 0. So this would be bring down your power, subtract 1. The derivative of the inside is just 1, so I don't need to worry about it. Plug in your 0 to here. I get 1/2. So your slope is 1/2. So then my linearization, usually we put the L of x, y equals, I don't care. But typically you'll see the AP exam use L of x instead of linearization instead of y equals, which is what we use for tangent lines. That's the only difference. So we're going to do, so y equals your slope, x minus your x plus your y. You don't really need the 0. I put it in there just so you guys can see. So really would probably just write this as 1/2 x plus 1. So either way. So over here, let's plug in the 5. And I'm going to get my calculator because I couldn't find my key to this. So I'm rekeying it right now as I'm making the video. So sorry if that's annoying. So we're going to have plug in the 5 here. I get 15e. All this is easy. So it's 10 minus 10. So we get 0. So then my y value is just going to be 15. And now when we take the derivative of this, put a little line here. Take a derivative of this, it's going to be a chain rule. I mean, a product rule and a chain rule. But leave the first alone, the derivative of the second. So remember the derivative of this is e to the 2x minus 10 times the derivative of the exponent, which is 2, plus leave the second alone times the derivative of the first. So this is the second alone, and the derivative of 3x is just the 3. So now plug in all your 5s into this. So we got 15, and that was still 0, times the 2. And 3 times, and that's still 0. So e to the 0 is 1. So that's 30 plus 3. So my slope is 33, I believe. And I'm not telling you I'm not going to make a math mistake as we do this, since I'm doing them so fast in here. So the slope is 33 x minus my x plus my y. Okay. Down here, let me plug in my -3 into my calculator real quick. So -3. Oh, I hate this. So -3, 4, -6, 3. Okay. So I believe it's 277. As long as I didn't make a mistake somewhere. So 277. So my point is -3, 227. Now I want to show you, because this is a really easy one, I want to show you how your calculator takes derivatives. So you should practice this by hand. But in case you forgot, if you do math 8, that's the derivative. So I could just put in x here. Here's my function. So I'm going to write down what this says. X to a power of 4 minus 6x cubed plus 3x minus 7. And I want that derivative to happen at -3 here. Hit enter, and then this should, so remember when I taught you this originally, that's a linearization of it. They use the limit rule. So really we have to know it's -267. So then my slope is -267. And when you do your delta math on this stuff, there is one where it says use your calculator. That means that you might not know how to take the derivative by hand. It might be that the derivative by hand is so ridiculous that he didn't want you to even try it. So here's the linearization of that. So let's see, my slope, x, and then my y. Okay. So I think we got that down. So we don't need to try another one. So down here now, what we're going to do is we're still going to write the linearization, but what most of the time the AP exam wants you to do is after you found the linearization, they want you to use it to estimate something. So what they're going to say is like use a linearization to estimate. So like for this one, we'd estimate -3.9. So that's why it says like to add 0.1. So like over here, I'm going to be estimating 2.1. Down here, I'll be estimating -0.9. So we're going to do everything the same as I did in the front part. So plugging in that, so that'd be 16. So square root of, so that would be 25. So my point is -4, 5, and then take a derivative, and this is the chain rule. The derivative of the inside is a 2x. So plug in -4 into that. That would be 25, so it's 1/2. 25 to that would make it 1/5. And then plug in -4 here, I get a -8. So what is that? -8/10. So -4/5. So that's my slope. So then I'd have a linearization of -4/5 x minus my x plus my y. And now what they want you to do is to plug in a -3.9 into this equation. And these are always non-calculator questions. So you have to have some little understanding of how this would work. So this right here would give me 0.1, which is 1/10. So then you're going to have to do like 1/10 times -4/5, and then plus 5 to it. So that gives me, divide these each by 2. I get -2. Let's see. Sorry, I just saw your text and Logan. -2 over 25 plus 5. So then my answer, the linearization of -3.9 is going to be what? 4 and 23/25. Okay. So let's try another one here. So plug in 2 into the original. What is it? 8 minus 4 plus 3. So it's 4, 7. So 2, 7 is my point. And now take a derivative. Plug in my 2. 10. So my slope is 10. So the linearization is slope x minus my x plus my y. And then you'd plug in your 2.1 here. So the linearization of that would be 10 times 0.1. So that's 10 times 1/10. Let me move my paper a little bit for you. So 10 times 1/10 is just 1. 1 plus 7, so I get 8. All right. So I think that we're probably good on this. Let's see what we got on the back. Oh, yes. So none of these are on the delta mass, but a lot of professors love this type of question, so I wanted to throw one on here for you, is that they love to use the linear approximation to actually figure out square root values. So you could type in square root of 1 of this in your calculator, and let's see what we end up getting out. Square root of 120. So I get 10.954. Now we're going to use a linearization in order to estimate it, and we should get pretty darn close to 10.95. So what we do is that we come to the closest perfect square, which is the square root of 111, and then we would write out the linearization. So I'm just going to do the problem down here. Actually, you can read through that. So if I want to do the linearization of the square root of 3, what I would do is I'm going to use the point 4 because that's the closest perfect square to 3. So then my point would be 4, 2. And then I would do the derivative of this. So plug in my 4 here. So 4 to a -1/2 would be 1 over square root of, so that would be 1/2. So I get 1/4. That's my slope. That's your m. All right, so then the linearization is 1/4 x minus 4 plus 2. And now I'm going to use the linearization to plug in 3. So then that would give me, so that's -1/4 plus 2. So that is, how did I miss? Oh, yeah. So this is, I was thinking of the answer from up there. 1 3/4, so 1.75. So let's see how close that is to the real answer. So 1.73, and the answer we got was 1.75. So pretty close. That's why professors think that this is like the greatest thing ever. This stuff down here, so all I'm going to tell you about this is that what the AP exam can do is when we take the derivative is that they could give you a change in x. They could also, instead of giving this to you, they could say x1 equals 2, x2 equals 2.05. And then you would have to say, oh, well, the change in x is 0.05. So all you would do would be to subtract these two. So if I wanted to know what dy was from this, I would take the derivative, so 3x squared, and there's a dx behind it. So instead of having the dx over here, which is really where it is, all we're saying is multiply the dx to the other side so that dy is by itself now. So then dy would equal 3, put in my x value, and then times the change. So it'd be 0.45. So that's the dy over dx. Now, just as a little side note, because I think this is on your guys' chest, if I asked you for the change in y, that would be like plugging 2 into the original. So let's see, we'd have 2 to the power of 3. So my y1 would be 2, and then y2, plug in this one, 2.05 to the power of 3. So I just plugged in the 2.05 now. So then this is my y2, 2.465. So then my change in y would be 0.465. And these answers should be pretty darn close to each other, saying that the change in y this way or the dy change here, they should be pretty good estimates. So that's your dy, and here's your change in y. And then this is the change in x, like subtracting it this way. So I'll just show you one more, because that one might have been confusing. So then dy over dx here, this would be a product rule. So I just took the derivative first, left the second alone. First alone, derivative second. So that would be 2x ln of x. Multiply over your dx. There you go. So then we would just plug in 1 into these, times ln of 1, and then the change of x. So ln of 1 is 0, so that goes away, so it's 1 times 0.01. So your dy would equal 0.01. All right. Let me know if you guys have any questions, and do your delta math on this.